This is my explaining material assignment in relation to quadratics, and the problem says that this quadratic here can be used to find the height of a rocket in relation to time, where h equals the height and t is the time. What we need to do is find the maximum height and find the equivalent method of getting that height by completing the square. So what we need to do to find this is convert this equation into vertex form. Right now it is in standard form, which says that y, or h of t, equals ax squared plus bx plus c. And we need to convert that into vertex form, which says that y equals a times x minus h times k. And the vertex is h and k. So we know that this is a quadratic, which means that if we were to graph it, it would look something like, so if this is our graph, it would look something like that. And it says, the equation says that it crosses the y axis, so this is the y axis, this is the x-axis, and the parabola crosses the y-axis at 60, right here. That's where it crosses the y-axis. So right here is 60. And we need to find the maximum height. So we need to find this point, right there. And that is why the vertex form comes in handy, because we can easily find that point. So, to start, I'm going to rewrite my equation so I have room to work. So, I'm going to replace h of t with y. So, y equals negative 3t squared plus 12t plus 60. I hate having t as a variable because this is like plus signs, but I guess I make them capital. Alright, so now we need to get all the any terms of the variable along on one side. To do that, subtract 60 from both sides. So subtract 60 from this side and 60 from this side. We now have y minus 60 equals negative 3t squared plus 12t. Okay, so what we want to do next is make sure that the a is a 1. So this, when we have something in standard form, it is the easiest to convert to vertex form when this right here is a 1. So what we're going to do is factor out that negative 3. To do that, let's redo this. So negative 3, to factor it out, we divide all the terms on this side by negative 3. So negative 3, and then put this in parentheses, t squared, and then 12 divided by negative 3 is, so 12 divided by 3 is negative 4. So we have t minus 4t. And that is our new equation. But what we want to do now is complete the square, because that's what the problem tells us to do. So to do that, we take this negative 4 and do this. So take that negative 4, divide it by 2, which gives us negative 2. Then take that negative 2 and square it. Right. And that leaves us with just plain old 4. And now we need to plug in this 4 on both sides. And I did that because, let's see up here, standard form, it has to have an a, b, and c squared, and c term. Right now it just has an a and a b. We need to, this is our new c term. And it makes it a perfect square trinomial, which is why we did it in that fashion. So we now have negative 60 equals negative 3 times t squared minus 4t plus 4. And whatever we do to one side, we have to do to the other side. So you might initially think that just add 4 to the side. But no, you can't do that, because we have this negative 3 here. So we take that 4 and multiply it by negative 3, and then add that to this side. So 4 times negative 3 equals negative 12. So negative 60 plus negative 12 equals negative 72. So once we add that to this side, y minus 72 equals negative 3 times t squared minus 4t plus 4. That is now equivalent, and we added everything we needed to both sides. But we are not done yet. Now we need to factor this down a bit more. So what we need to do is, so y minus 72 equals negative 3, and then do t, and take this term right here, the b divided by 2, which in this case is negative 2, minus 2 squared. And we did that because it looks very similar to this vertex, and it is equivalent. If you were to expand this into negative 3 t minus 2 times t minus 2, and let's raise that up a bit, and work that out, you would find that it is equivalent to this and this. But this is just the easiest way to write it, and it looks the closest to the vertex form, which is what we were trying to do. So that is why we put it like that. And now we have one more short step. Get this y by itself. To do that, we add 72 to both sides. So we have y equals negative 3 times t minus 2 plus 72. That's now in vertex form. And we are super close to figuring out what the maximum height of our parabola is. As I said earlier, up here, vertex is the h and k values. So you may think that the vertex would be negative 2 and 72, which would look like this. But that is incorrect, because if you look at the vertex form up here, it's negative h, not h. So whatever this term is, we need to take the opposite sign and use that as a vertex. So the real vertex is 272, not this one. And that is our vertex. And this, so this is the x, this is the y. So if we go back to our graph, I'll make it a bit bigger down here, actually. So we know that it crosses the y-axis at 60. So let's say this is 60, 1, 2, 3, 4, 5, 6, so on and so forth. Our vertex is right here at 2, 72. So the maximum height of the rocket is 72 meters.